Welcome to our YouTube channel Medical Subjects Made Easy. Today's topic is p-value and its importance in biostatistics. In biostatistics, the concept of p-value is a fundamental and widely used tool for hypothesis testing. The p-value is a measure of the strength of evidence against the null hypothesis, which is the default assumption in statistical inference. Definition and calculation of p-value. 1. Definition. The p-value is defined as the probability of obtaining a test statistic at least as extreme as the one observed in the data, assuming that the null hypothesis is true. 2. Calculation. The specific calculation of the p-value depends on the hypothesis test being performed. It is typically calculated using statistical software or tables based on the test statistic, sample size, and the assumed distribution of the test statistic under the null hypothesis. Interpretation of p-value. 1. Significance level. The p-value is compared to a predetermined significance level, alpha, commonly set at 0.05 or 0.01. If the p-value is less than or equal to the significance level, the null hypothesis is rejected, indicating that the observed data is significantly different from what would be expected under the null hypothesis. 2. Null and alternative hypotheses. The p-value is used in conjunction with the null hypothesis and alternative hypothesis. The null hypothesis typically states that there is no relationship or difference between groups, while the alternative hypothesis states the opposite. The p-value informs us about the plausibility of the alternative hypothesis. 3. Statistical evidence. A low p-value, e.g., less than 0.05, indicates that there is strong evidence against the null hypothesis and provides support for the alternative hypothesis. Conversely, a high p-value suggests weak evidence against the null hypothesis, indicating that the observed results could reasonably occur by chance under the null hypothesis. 4. Type 1 and Type 2 errors. It is important to note that the p-value does not directly provide information about the probability of the null hypothesis being true or false. It represents the probability of observing the given data under the assumption that the null hypothesis is true. Thus, the p-value is associated with type 1 error, where the null hypothesis is wrongly rejected when it is actually true. Type 2 error, which is the failure to reject the null hypothesis when it is false, is complementary to the p-value. Limitations and considerations. 1. Sample size. The p-value is influenced by the sample size. Larger sample sizes tend to lead to smaller p-values, as smaller differences become statistically significant due to increased power. 2. Multiple testing. Conducting multiple statistical tests on the same data can increase the probability of obtaining a significant result by chance alone. This issue is addressed by adjusting the significance level, e.g., Bonferroni correction, or by considering the p-value in conjunction with effect size and replication. 3. Assumptions and interpretability. The validity and interpretability of the p-value rely on several assumptions, including the appropriateness of the statistical test, the underlying distribution of the data, and the independence of observations. Violations of these assumptions can affect the reliability of the p-value. 4. Contextual importance. It is crucial to remember that the p-value alone cannot determine the practical or clinical significance of the findings. External factors, such as the magnitude of the effect, relevance to the research question, and contextual interpretation, should be considered alongside the p-value. In conclusion, the p-value is a vital statistical measure in biostatistics that provides an indication of the strength of evidence against the null hypothesis. Understanding the calculation, interpretation, limitations, and careful consideration of contextual factors are essential for appropriate utilization of p-values in biomedical research. If you found this video interesting, please like this video and subscribe to this channel. Thank you for watching.